Hello class, today we're talking about evaluating expressions using order of operations. So first we have to go over the steps on how to evaluate an algebraic expression. So we're going to rewrite the expression, replacing the variable with the given value in parentheses. So now we're going to simplify using the order of operations. So we're taking some kind of algebraic statement with our variables. We're telling you, okay, x is actually equal to this, and then we're going to simplify it. So it is very important to use parentheses because once we start getting into the order of operations, it's really important to keep track of what we're supposed to be doing first, make sure we're keeping track of the negatives. So if we were to do it with parentheses, I'm just going to take whenever I see an x and I'm going to replace it with a -2. So it starts with -2 squared minus 2 times x. So when I say times, it means I'm going to put it in parentheses right next to it, and then plus 3. So order of operations tells me to do my exponents first. So when I see this exponent right here, -2 squared is -2 times -2, which is 4. And then it helps to kind of rewrite the rest of your steps that you haven't done yet. And then I have my multiplication, so I'm going to do 2 times -2, which is -4. So I'm going to say 4 minus -4 plus 3. And then now, because I've got my addition and multiplication, I'm just going to do whatever comes first from left to right. So 4 minus -4, if we see those two minus signs right next to each other, we could think of that as plus. So I'm really saying 4 plus 4, which is 8 plus 3. And when I simplify 8 plus 3, I get to 11. So it's important to keep your parentheses, because if I didn't have parentheses, I'm going to get a completely different answer. So I'm going to show you guys what it might look like if you guys made a mistake and didn't put the parentheses down. So I'm going to do the same thing, except no parentheses. I'm going to say -2 squared minus 2, I guess, because x is -2, plus 3. So already very confusing, because I'm not totally sure what's even going on. So I can start with my exponents first. This looks like 2 squared to me, which is 4, but remember that negative sign is out there, so I guess I'll write it down. And then I have this -2 minus 2. So already, right here, I'm very confused. Am I multiplying? Am I subtracting? That's why it helps to keep your parentheses, because if the parentheses are here, you definitely know what you're supposed to do. But I guess we could say -4, and then let's say it's subtraction. So it's another -4 plus 3. Already you can see the answer is a little different. -4 minus 4 is -8 plus 3. And then when I do that simplification, I end up with -5. So you can already see that something went wrong. Next, we're going to talk a little bit more about the modeling piece. So we talked about the modeling piece in class. So if I were to model this expression 3x, we remember that the long rectangles represent our x's. So I'm going to draw 3 of them. And now it's telling me, okay, it's not x anymore. X is actually equal to 2. So each one of these is going to represent 2. And when I add them all together, I end up with 6. So I can do the same exact thing, but without having to draw those rectangles and squares every single time. If I know my expression is 3x, and I know that x is 2, well, let me just substitute like I did up here. Let me just take every time I see an x and replace it with a 2, in parentheses, of course. So now I have 3 with a 2 in parentheses. If they're right next to each other, that means I'm going to multiply, and 3 times 2 is equal to 6. You'll notice no matter how we did it, we still got the same answer. We're going to do a couple more together, and I'm going to give you guys the rest of to work on your own as kind of like a practice. So again, I have my expression. The first thing I need to do is to replace those variables with my actual number. So I have 8x divided by 6, right? That fraction bar means divide. So I'm going to do 8 times x, and keep those parentheses, divided by 6, minus 2 times x, And now I'm going to simplify and do my order of operations. So this fraction bar is a grouping symbol, so I'm going to do my grouping symbol first, and it looks like I need to do my multiplication up first as well. So 8 times negative 3 is negative 24 over 6 minus 2 times negative 3 minus 3. Looks like I've got some division here that I need to work on, so negative 24 divided by 6 is negative 4 minus 2 times negative 3 minus 3. And it looks like I ran out of room a little bit. Next, I've got a little bit more multiplication here that I need to work on, so I'm going to kind of cheat and write it up here. So it starts with negative 4. Again, if you're not doing anything with this part of the problem, like you'll notice this negative 2 times negative 3 minus 3, I wrote that 3 times now because I didn't do anything with it. So if you're not working on that part of the problem, you can just keep writing it. But I know I'm starting with negative 4, and then I've got minus 2 times negative 3. Well, 2 times negative 3 is negative 6. So I've got minus negative 6, and then minus 3 at the end, and then now I've got all addition or subtraction, so let me work through that. Negative 4 minus 6 is really the same thing as negative 4 plus 6, which is 2, minus 3, and then 2 minus 3 gets you negative 1. So the same thing is going to work no matter what your numbers are, no matter what your expression looks like, it's always going to be the same steps. So first I'm going to simplify by substituting my variable into the expression. So I've got 2 plus x cubed, but it's really 4, so I'm going to write 4 in parentheses, cubed, and then this whole thing is being divided by 3. Now you could write it like this, and I think we should get into the habit of writing like this. So if I'm dividing it by 3, let me just make a really big fraction bar and actually put that 3 on the bottom so I know that I'm dividing it by 3. Looks like I've got some stuff on the top that I need to work through. So I've got 2 plus 4 cubed is 4 times 4 times 4. In case we're stuck on what 4 times 4 times 4 is, well, I know 4 times 4 is 16. And then let me do 16 times 4 really quickly. 6 times 4 is 24. 4 times 1 is 4 plus 2 is 6, so it's really 64. And then I'm dividing all of that by 3. Don't know what happened here. Let me grab that. Can I grab that 3 on its own? No, I can't. So I'm just going to erase the whole thing. So I've got 2 plus 64. All of that divided by 3. And I know what 2 plus 64 is. That's easy. It's 66 divided by 3. And if I do 66 divided by 3, I get 22. And you can see some of these have absolute value. Some of these have different variables. It's not always going to be x, but the idea is pretty much the same. Start with substituting. So here I have 2 variables. So as long as you're keeping track of what variable is what, we should be okay. If I do x equals 2, so I'll substitute x for 2. So all I'm doing is looking at the problem here, replacing those variables with what the variables are actually equal to. So in this case, parentheses are going to come first, so 3 times 2 is 6, plus 7.5, whatever that is. And I'm going to subtract whatever the absolute value of 5 is. Let's do these parentheses first. 6 plus 7.5 is 13.5, minus the absolute value of 5. And then we know what the absolute value of 5 because we just took that test. And then 13.5 minus 5 is equal to 8.5. And lastly, I'm looking at this problem up here. It's talking about Celsius. Celsius is going to represent that C right here. And then again, I'm just taking that expression, and I'll rewrite it so you guys can see it more clearly down here. I've got 1.8 C plus 32. Well, I know what C is. C is 11. So let me do 1.8 times 11, add 32. And when I do my simplifications, I end up with the answer 51.8. So there are a few more that I want you guys to do, draw them and evaluate, and then there's a couple of order of operations expressions as well.